Hello. Today I'm just going to take you all through this lecture quickly. This is a short one. Um, and we'll just kind of get through everything. Making sure it's recording. It's recording. All right. So for this one, this is about data misrepresentation because this week is about ethics. Remember to do your 1619 project. But here we have there are often misrepresentations of statistics on different channels. Sometimes it's malicious, sometimes it's not, sometimes it's laziness. We'll see lazy, maybe some maliciousness actually. Um, Whereas right here it says Trump won the majority of white voters, and while that's true, they try to really exaggerate what's going on here because you see here the pie slice is like actually around 70%, around that. And they have it listed as 57%. So it makes it look like way more white voters supported Trump in that election. It's one way to do it. So just make sure when you're doing your numbers on your pie chart that they actually represent the proportions of the slice. Here's an example of malicious data misrepresentation. And it just kind of shows the other way around, just a straight up lie. Where Biden actually won this race, well, the race currently, right? But Biden lost. It even fooled me. Biden lost, but it was trying to represent Biden as winning there. The next slide is lying, and the author changes the scale from one graph to the next, which made the visual representation tell a false story. This is from Benford's law, but I just kind of want to show you like exactly what scale means. So this is your scale on the left side here. See here? And there's another scale down here, 14, 12, 10, 8, 6, 4, 2, 0, 8, 8.5. So we have an intervals of 0.5 on this scale and intervals of 2 on this scale. Now this data is exactly the same as this data. The only difference is how it's being measured out in distance between each other. And they are equal units. So, it's fair on both sides. It's just if you increase the scale, it kind of crunches the line chart down, and it makes it look, a little bit different. Even though it is actually the same chart, you can see it's the same chart, um, in a way. So, because there's a dip, point, point. You can't really tell what's going on there because it's a little bit. There's a spike right there, and so that being said, a smaller scale will show more detail. A larger scale will show less detail unless you're working with big numbers. If you're working with big numbers, use a larger scale. If you're working with small numbers, I would go with this one right here. And just to kind of show you exactly what's going on with that, these are different unit of analysis is going on with this picture. So as you can see here, measurement and magnitude unit of measurement. This is unit of measurement is land, where it shows all the red. Unit of measurement people, land, and people. And you can see just how different it looks, by voter. So if you measure by people, it shows, concentrations of people who voted, and then concentration of districts. So it kind of paints a different picture depending on which unit of analysis you measure. Again, this is if you're using land and if you're using people. This is inappropriate scaling on the ordinal level. It looks all red, so it's hard to tell what's going on for real. What they really need to do is just make other categories besides uncontrolled spread, or at least more detailed into the uncontrolled spread, because there's differences in those each states. Kentucky wasn't really that bad at the beginning of COVID, and we do have a lot of drama going on in the tweet too, but yep, that's just they need more details in the upper categories. So always check your unit of analysis, always check your scale, always ask for 100,000 per population data. For example, how many murders per 100,000 people? If it's 2.4, that means it is 2.4 murders per 100,000 people. For experiments, try to have a good idea of what the methods of the study were. If you have any questions, feel free to hit me up.